welcome to Paris Mountain State Park in Greenville, South Carolina. I'm Ranger Kathy Taylor. Welcome also to part 3 of our Forest Ecology on-site program. Remember, you are our scientists for the day. In parts 1 and 2, we started our journey around Lake Placid and into the forest a little bit at stations along the trail. Along the way, we figured out what's so fantastic about forests. We know this forest was set aside over 100 years ago to protect the water supply back when this was Greenville, South Carolina's drinking water. In part 3, we'll use what we figured out in parts 1 and 2 as we go farther into the forest and do a 1 square meter investigation. Let's get started. You will need your forest ecology field study sheet today. Where it says ecologist, that's you, so you can write your name there. We'll be using this sheet as we walk around Lake Placid, figuring out what's so fantastic about forests. After we practice being forest ecologists as we walk around the lake, we'll use the other side of the sheet, or page 2, to do a 1 square meter investigation of the forest. Station 8 is just before the area where we'll do our 1 square meter investigation of the forest. So let's get to know the tools we'll be using in our kit. So we're going to use 1 thermometer to measure the air temperature, seeing where the red line goes up to, and another thermometer to measure the soil temperature, placing this in the soil. This will be in Celsius, by the way, because scientists all over the world use Celsius for measurement instead of Fahrenheit. We'll also be using pH strips, and we'll use those to measure the acidity of the soil. It's basically color matching, where we will take a pH strip and place it in a vial of distilled water combined with soil from the forest. Distilled water has a pH of 7, and on a pH scale, 7 is right at neutral. So you could add something like soil to it to make the liquid that you need to determine the pH of the soil. So 7's neutral, lower than 7 is considered acidic, increasingly acidic as you get to lower numbers, and above 7 is what we call alkaline. And so we're hoping to get somewhere near 7, but sometimes we naturally have a slightly acidic soil here. So we'll be color matching to see where the colors match up best with what number. We'll have a timer so we can measure how long we do our abiotic measurements. And for our biotic part, we have a magnifying glass to maybe see some animals up close, and also a little box we could just use briefly maybe to put a little animal in and look at it with a magnifying top. We're taking a little side trail to go up to where our student forest ecologists get to know the forest up close, 1 square meter at a time. And this will be our square meter today. Let's get started with our square meter investigation. For abiotic factors, it says to first set up air and soil temperature by holding the blue thermometer in the air and placing the silver thermometer in the ground. So let's put the air thermometer, you know what, I'm going to put it on a stick. More hands-free that way. Isn't that smart? Okay. And for the silver thermometer, let's put it in the ground. See if it'll go in there. Don't want to hit a rock or rooter. So, all right, silver thermometer is in the ground. Now, let's get our pH test ready. By placing a pinch of soil in the water vial, shake, then dip the colorful end of the pH strip in the water. So, let's get a pH strip out. And we get our vial of distilled water. Why is it important that it's the distilled water? Well, we know that that will have a pH of 7, or neutral on a pH scale. So the pH that we get if we add soil should just be the soil pH. So get some soil, get past some leaves here so I get actual soil. I'll put it into the vial of distilled water. Shut it well and shake it up. And I put the pH strip into the vial of soil and distilled water mixture. Just enough for it to saturate, to get all wet. And then I'll bring this out. I might as well dump out that water. And I'll place this strip onto a pH chart, a color chart. And before we try to read that or the temperatures, I'll set my timer for 2 minutes, get everything a chance to settle. Okay, 2 minutes has passed. So let's get a little closer so we can read the thermometer, temperatures, pH strip reading together. So let's take a look at the air temperature. See the 0, the 10, the 20. Where does the red line go up to? Is it above the 10? Yes. Is it above the 20? Well, write down the number you get on your field sheet. And no, this is in Celsius. That would be pretty chilly if we were talking about in Fahrenheit. And then let's look at our soil thermometer. And, oh, it's a bit lower. Do you see a 10 and a 20 there? A 0. This is Celsius, remember. Is it between the 10 and the 20? Or if not, is it between the 0 and the 10? Or write down the number that you would say it's closest to for soil temperature. Finally, I'm going to check our pH chart. And we'll look at the colors on the strip. And sometimes it's good to start with the green and then look at the other colors after that. But it definitely doesn't match, the strip doesn't match the low acidic numbers, very acidic numbers, or the very high alkaline numbers, does it? It's closer to neutral at least, which would be 7. So what number are you going to use to write on your field sheet for pH today? So for biotic factors, it says to look under the leaves and the soil for animals. Place a check mark by any animal that you find. So, let's see, look around. We found a snail. There is a place to draw an animal on your field sheet. The snail doesn't move as much as some of the others. If you'd like to use this opportunity to draw that spiral shell. I did see a little snail in there. Wait to see if it will come out. Found a nut. We found a millipede. Now millipedes, unlike centipedes, will just eat old plants under the leaves. Ooh, and now we found a bigger millipede. Goodbye. We seem to have a little baby termite walking around. Oh, there he went. Oh, there he is. Surprisingly moist under here because we haven't had much rain lately. Look what we found in our square meter area, a centipede. That is an animal we don't want to handle. But if you can draw it with all those little legs, centipede means 100 legs. It doesn't have that many, that has a lot. Wow. I find this kind of funny that I've been looking for little animals and some little bitty ants actually made their way into the little kit we have here. So maybe this will be an opportunity for you to draw an ant. We know, since it's an insect, we know that it has 3 body parts. And how many legs? Should be 6, right? It says to list some types of plants in your square meter. Well, this is a pretty good square meter area when we're thinking about forest succession. because we have some green plants with briars on them. In other words, we have a little pine tree growing, and we have, let's see, we have a oak tree, a white oak tree right here, very little, in addition to a sweet gum tree growing. So we have, oh, and let's see, we even have some grasses here. So we have many parts of forest succession there. So you can write down some of the types of plants that we mentioned, like green briar and pine, oak, and sweet gum. Oh, grass. We were asked to find some fungus among us if possible. At least that's one way of putting it. I don't see any mushrooms, but I'm seeing some white stringy stuff that might be associated with the underground part of a mushroom. And I did find some fungus here. This stick has lichen on it, and lichen is really part fungus, part algae. The fungus and the algae work together to make lichen. And let's see. In your square meter, name a producer and a consumer. Well, let's say pine tree, or you can decide which producer, which plant you want to put. And what about for an animal? What did we find? Well, what we found out by getting up close to the forest in this 1 square meter area? Well, one thing I found interesting is the Abed factor of temperature was so different from under the ground versus up in the air. But you can imagine how important it would be for animals who are trying to get their body temperature where it's at a comfortable level to be either above ground or below ground. And when it gets cold enough in the air, the underground will actually be warmer. So animals like box turtles will go under the ground, and actually many animals will. Turtles. We know that turtles are exothermic. Sometimes people say cold-blooded. They warm up from the surroundings, and on a sunny day like today, they're going to take advantage of that sun shining on them as they sit on a downed tree that used to be upright in the forest, but is now a good place to sit if you're a turtle. Oh my goodness, we don't see this every day. Instead of turtles sunning on a downed tree, we have Canada geese. Well, scientists, we've almost finished our walk around Lake Placid today. I wanted you to see the park center porch and building here on the way. The Civilian Conservation Corps built it in the 1930s. After the lakes and creeks here were no longer part of the water supply, the Civilian Conservation Corps came in and built a state park. So visitors to the park certainly enjoy the trails and enjoy being in the great outdoors here. I wanted you to see an animal that enjoys the rock walls in particular here. It's a good climber here. I'm talking about a black rat snake. Oh. Well, the beavers have been busy, haven't they? We made it back to about where we started from. And I hope you figured out some of the amazing ways that forests are fantastic. Thank you for being here today. We need people like you. We need ecologists who understand the relationship between living and non-living parts of a place. Why? Well, let me ask you, is having enough food and water and shelter and space important to you? Is it serious business to know that you have what you need to survive? Well, the more we come to understand the amazing ways that the forest works, the more we come to understand that every turtle we saw today, every bird, every insect, every snake, considered it to be serious business to have what they need to survive. Why do we need to understand the way that a forest works or the way this world that we all live in works? Well, the more we understand, the better we can care for it and appreciate it and enjoy being in the great outdoors. I hope you get outside a lot.